Cloud Solution Architect on my team in the Northeast. Okay.
All right, thanks, Tim. Thanks again for hosting this and giving me the opportunity to talk. Today, let me just start sharing my screen and then we'll keep going. Um, so you guys can see my screen now, right?
Yes.
Okay. All right. So my name is Jay Kumar. I'm a cloud solution architect with Microsoft. I actually primarily focus on the app and infra side of Azure. So in today's session, thanks again, everyone, for joining. So in today's session, we are going to talk about security, and just a premise to this discussion is security is a very vast area, right? So there are several areas in security that you cannot cover within an hour time frame. So what I'm trying to do here is to give you some high level overview of how Azure security will look like, and probably kindle some interest in you guys to like look at those areas where you find more interest in, and at least kind of break it down to some of those pillars of security, and then we'll look at those and then go from there. So with that, let me just move to the next slide here. Again, when we are doing some applications or you're doing infrastructure and apps in Azure or your data, everything in Azure, the security is a partnership in that scenario, right? Security is not going to be all like we have when you have something in on-premises. Everything is going to be your responsibility, but when it's going to the cloud, it doesn't mean that everything is Microsoft's responsibility. There is also a part of the puzzle that you own in terms of the foundational and the fundamental aspects of security, the traffic registers, and all that stuff is provided by Microsoft. Like, can you, one of you guys mute? Sorry, I'm getting some feedback. Um, so, the part of the thing that is owned by the customer is around the application security and the data security, but infrastructure wise is all Microsoft's responsibility. So this actually is a little bit more explained in this diagram here. So we all know that in a cloud model, there are different tiers of service, right? So you start from SaaS to all the way to IaaS. And also there is this component of on-premises, which is totally your responsibility from a customer point of view. So from if you look at the SaaS, most of the things are taken care of by the provider, and the things or the responsibilities that are for that the customer is responsible for is data governance, the client endpoints, account management, and identity management, and all that stuff. Basically, it is a provisioning process, right? You just make sure that you have the right people having access to the system, and you have the endpoints secured. Like when you are like trying to give external people access to your systems and all that, you're not exposing some things in your systems. Those kind of things are primarily focused around the customer. And on the far end, you have the on-premises environment, which is totally your responsibility. And between that, there is varying levels of responsibility gradation that you can see here, right? If it is a PaaS service, it varies, right? It depends on the type of service that you are subscribing to. There could be some, like mixed responsibilities here. So this is the whole concept of a shared responsibility model in security. All right. So if you look at the philosophy of how we protect customers, any security model has three things here, right? We start off with we have to proactively protect our customers from security threats. So, and again, we don't assume that everything is going to be secure. Security is going to be a living process. It actually, keeps strengthening, and we keep it strengthened, and then just evolve as time goes because new threats come up, new, new events happen and things like that. So we always assume that there is going to be a breach, and we assume by the assumption that there is going to be a breach, and go from there. And the first part of that is called protection, right? So we should have the tools and capabilities to protect you from all the known threats and all the known security vulnerabilities and everything. So we need to protect customers based on that. And then detection, right? So which also means that there will be new detection, there will be new security events happening, threat vectors coming in, and so we are going to have some sort of analysis and detection of those kind of events. And that's begin looking for known intelligence within the telemetry that we are getting. So security is not going to be a siloed event, like just somebody trying to change a password is not. We are not going to view that as in a siloed concept, right? There could be other things that the same person is doing. They may be trying to flood something else. They will be trying to do multiple things. So there is a correlation of all these things. So based on all our experience in the past, we collect all these things and we create a graph of all that. And then that's the AI part of the security comes into picture, right? So we keep modifying our security model based on that, and that's how the detection process. And then we try to respond to that. So the process should be resilient and fast enough to respond to any detection. So we provide you the tools and capabilities to do that. And again, this is a cyclical process. And it actually, once you find out more about the new threats, we have to incorporate to that the protection process, and then it kind of goes on. Like that is the full life cycle of a security process. And Microsoft takes security very seriously. We spend more than $1 billion every year in terms of security alone. So we have a lot of security products. We have several things. I can cover some of those things today. And let's move on to the next slide here. So the first part of the security is the physical security of Azure. So how are we protecting our data centers and regions and all that stuff? And everything is this is the first line of defense, right? We have to protect everything under the cover. So this is very important. So in terms of physical security, all of the Microsoft cloud offerings are provided on a foundational layer. It's a common infrastructure operated by a team called the Global Foundation Services, and everything is built on top of that. So underneath the cover, you have all the physical assets like the servers, the physical machines and the hosts, the routers, wiring, power supplies, all that stuff sitting within the data center. And on top of that, we have the IaaS, which is infrastructure as a service, which is basically virtualization on top of the physical assets. You actually create compute, storage, and networking in a virtualized fashion on top of that. And that's the IaaS service that we provide. We provide you virtual machines, we provide you storage, and it also provides the software-defined networking that ties all these things together. And on top of that, we have the PaaS services. The PaaS services are built on using the infrastructure services. Like PaaS services are more platform, so that you don't have to worry much about the infrastructure as such. Like you don't have to worry much about upkeeping those infrastructure elements. And on top of that, there are SaaS services. So that actually gives you a clear picture around how the responsibility shifts from PaaS services all the way to SaaS services. Basically, once you are in an IaaS model, then there is more around the server security that you need to care about. Once you move to the SaaS model, then all those things are encapsulated within the framework of the SaaS product. So with that, let's look at what we provide in terms of security for our data centers. So basically, we have, I think, around 60 plus data centers right now, or 60 plus regions, and around hundreds of data centers, and some regions have multiple data centers, right? So you have all these things, and then there is going to be a full-blown process that actually makes sure that this is all protected. And there are background checks and system checks and biometrics checks and all that to enter the system. And again, not all Microsoft employees are even allowed to do that. And the Microsoft employees who are working within this environment are not able to identify which of these servers belong, or like which servers host which customer. Like it's it is like not known to those guys. Basically, it is all hidden, and they cannot pinpoint where somebody's data or somebody's access is, all that stuff. So that's the first part. Then there is perimeter security. There is 24/7 video coverage, all that stuff is usual standard stuff. And then there is this the building security and the server environment security and all that. So I don't want to go too far, but there is a very strict standard process that is actually followed across all these data centers to protect all the assets that is sitting out there. That's all about the physical security of the data centers. Now let's look at the networking part of it. So basically, like I mentioned before, that security is divided into several concepts. Like you have network security, you have application security, data security, and then you have operational security, which is like all about your security ops, SecOps, we call it. And there are all these pieces. So I'm just trying to point you to different things. And there is also several other pieces, like in terms of logging, monitoring, alerting, all sorts of things that is actually common across several of these things. So let's look at some of the aspects of network security. So if you look at the network big picture, so if you are in an on-premises environment, you have a local area network, which means that all your servers and computing environment is within a local area network or LAN. And if you are looking at your home environment also, you have a local area network. You have a router that is sitting and facing your internet, and everything behind that is a local area network. And those are called private IP addresses. And those private IP addresses will be common IP addresses, which I and my neighbor will have probably may have the same IP addresses, but that is hidden from the common infrastructure. So that's not the public IP space. So the same concept, because and again, the Azure is a public cloud environment. So the concept of private IP addresses is called the actual Azure virtual network. So what we do is we actually logically carve out a space within Azure and provide you as a virtual network where all your private IP addresses reside. And then you will create servers and assets there, which actually have private IPs, which are similar to the way that you are doing it in on-premises. And it becomes like a logical extension of your on-premises environment. That's called the virtual network. And then you have the customers or the users of this system that are coming from external. They are uncontrolled domain, which is coming from outside your domain. And these are all users trying to hit your application using a public endpoint. This is similar to how you're doing it in on-premises also. Like you will have an application that is hosted in on-premises. The people who are managing the application will be accessing them internally using private IP addresses, but they may have a public endpoint where the customers will be connecting to. Similar to that, the users come through internet, and they connect your assets or like products through public IP addresses. And then you have the backend connectivity. So this is required because physically the private IP addresses are not sitting in your on-premises. You will have to have some mechanism of like extending your data center into cloud. So we use express route or VPN connections from your on-premises to the Azure. So basically, it becomes like an extension of your data center. So this is the whole model of the network infrastructure. So I just want to give this background information and how this is going to, we are going to talk about how these things are protected. Now look at next thing I want to talk about is the network security groups. So when you create a virtual network, you are isolating the network segment and putting all those things there. So you can have multiple virtual networks, and by default, the virtual machines sitting in one virtual network, VNet, cannot talk to another VNet. It has to be opened. So that's all the concept of network security groups come into picture. Network security group is pretty much like a rule which takes 5 components as inputs, such as input like source IP addresses, source port number, destination IP, destination port, and the protocol that it has to talk to. Like basically, if it's a HTTP protocol or like FTP or whatever it is. So we have a rule, and then we will say allow or deny for that particular. It's like a 5 tuple if you look at the way you explain it in mathematical form. So it's a 5 tuple where it is having all those inputs, and then there is an output which is the allow or deny. And so you can chain all these rules, and you can say okay, allow these things and deny everything else, and that way it will be protected, and then no traffic can go through from one component to the other across these NSGs. And this is one way of organizing it. Then we have application security groups. The application security group is a logical extension to NSGs, because when you have when you're building an application, and again, going back to the NSGs, I just mentioned that NSGs actually take IP addresses or a range of IP addresses as inputs and outputs, or like destination and source. But when you are building an application, there may be several layers of the application, such as the web servers, app servers, and databases, and things like that. And then you may be having these in multiple VNets and everything. So it's difficult to put so many rules. Like, you have to like take one server at a time, and then just write so many rules. So you create application security groups, which actually it's a named element, right? You have an application security group, and then you can actually add similar servers into that app security group, and then you can actually use that in the NSG rule. For example, it's more like a grouping in a very simple sense. Like okay, I have app servers like VM1, VM2, VM3, which has IP address 1, 2, 3, and 4, and then that's a group. And then I use that in my NSG rule. Okay, this group can talk to this group over this protocol, things like that. That's as simple as that. So we have that facility also for protecting your servers. Now the next thing is around how we build an enterprise application in Azure. So first of all, an application could be deployed across multiple regions. So we will have a load balancer at the top level, which is called traffic manager. We also call it global load balancer. And then there is another similar capability called the Azure Front Door, which also can be used. But anyway, that actually takes you the customer. Like in the first diagram, I showed you how a customer is coming from external from the internet and then trying to connect to your service. And this is that flow. Actually, the customer is coming from the internet and trying to hit a public endpoint of your system. And then you don't want to have a single point of failure. You're not providing a single server IP address for this customer. We may have a redundancy. We may have the same application deployed across multiple regions. So you want to load balance those guys, and then for high availability and things like that. So basically, this load balancer comes in, the traffic manager comes in the front, and then it actually dispatches this request into region 1 or region 2, depending on the rules that you set up on the load balancer. It could be a proximity-based rule, or an availability-based rule, or a round-robin rule, which actually goes one by 1, 2, 3, 4 in a round-robin fashion, things like that. But anyway, it goes to one of these regions, and we have load balancers there, and then we can do application gateways. And I don't want to go too far into that because it's not like a networking discussion. But anyway, there are different layers of protection we can do, and this is more around load balancing and availability. But then there are things like the application gateway gives some more features here. So the application gateway is a layer 7. Layer 7 means it is an HTTPS application aware protocol. So you can actually put rules there. Like the application gateway is a load balancer as well as a WAF. A WAF means it's a web application firewall. So so you can enable the WAF capabilities of application gateway, and it provides a centralized protection for your web applications. So there is an open source of a known threat vectors for all the applications from a project called Open Web Application Security Project, or OWASP. And WAF actually by default implements all those protections. And you can add on top of that. You can have your own protections on top of that. Okay, if this particular the web request has some sort of signature like a cookie or whatever it is, don't allow it to do some things and things like that. You can put those kind of rules as well in the app gateway. So that's all about app gateway. If anybody has questions, please feel free to just interject me, and then
Yeah, I'm keeping an eye out.
okay, cool. All right, so let's go to the next slide now. Then the next one is around how you compare between an on-premises network versus a network that is deployed in Azure, right? In an on-premises network, you will have a traffic coming from internet is usually so let me talk about the topology of the network. So you have something called a DMZ, which is called a demilitarized zone, and then you have the internal network, right? Basically, DMZ is also called the perimeter network, right? So when you don't want to have your customers or the people coming from outside your organization directly hit into your actual web or actual backend servers, or like the application hosted there. So you usually have proxies in the front, right? Just to cut off all those things at that level when there is an issue. So that's called the DMZ, and that's where the firewalls and things like that will reside. And then the internal applications reside in the backend network. So we usually call it the control domain, and then the other one is called the perimeter domain, perimeter network and the control network. So that's the traditional way of having in an on-premises environment, and all these networks are firewalled off between each other, and you'll have strict rules across traffic going back and forth. So the idea is to have the threats mitigated at the DMZ level itself. So in terms of Azure, we use network security groups for that. And then you can also supplement this with Azure firewalls and all that. I don't want to go too far into that, but there are other. This is the basic stuff I'm talking about from the Azure side. So in the Azure, you have a front-end subnet where you have all your front-end protection similar to your DMZ, and your backend subnet where you have your backend. And then you can actually put other controls around like application gateways and WAF and Azure Firewall, and also do some sort of virtual appliances and all that. That's actually in addition to what all these things provides. So that's actually called UDR, or user-defined routing. By default, when traffic comes into Azure, it gets routed into the front-end subnet and then goes to the back-end subnet. But you can actually put in some things like called virtual appliances. They're all just like they're all like like, for example, Palo Alto firewall. So those guys actually provide hardware devices that you can put on premises, but then they also provide images of those hardware devices, which can be hosted as a virtual machine under a virtual machine in Azure. And we don't call it a virtual machine, it is called a virtual appliance. So those virtual appliances can be put in Azure, and then you can route your traffic through those virtual appliances. Because by default, the Azure routing doesn't know about this virtual appliance, and so you have to do a user-defined routing. So basically, whenever whenever a traffic comes into Azure, you are telling the traffic to go through this virtual appliances, which is a security device, which could be a sniffer looking at the packets that is going through, and then alerting something and things like that. So you could do those kind of things, and that's achieved through user-defined routing on virtual appliances. And you can see there are a ton of capabilities like the Citrix, F5, Aviatrix, and all kinds of products available that you can actually implement on top of the standard Azure security model. right? So then encryption in transit. All the traffic that is going from Azure to any one Azure resource to another Azure resource within the Azure framework is encrypted. Most of them actually, and then so basically, let's say you have a virtual machine A is sending a traffic to virtual machine B, even though it is going internally through Azure framework. It is going to be encrypted at transit level. So basically, that's the traffic. So you don't have to provide anything for that. It is by design, and unless you are actually doing some sort of HTTP connection or like some sort of programming model that overrides that. The next thing is all about DDoS protection. I'm hoping that everybody is familiar with DDoS. DDoS means distributed denial of service. These are the attacks that people try to flood an application with so many requests that the application cannot handle it and then eventually dies. One of the most common DDoS attacks is called a SYN flood. Basically, it actually tries to establish a TCP/IP connection and send a lot of synchronization packets and then never acknowledge them. And then then the server will start opening so many connections and cannot close those, and eventually it will die and things like that. So there are several ways of doing DDoS. There are two different protections in DDoS. First of all, the whole Azure is protected against DDoS, like not from a single customer point of view, right? Azure as a framework, Azure as a offering, like the whole cloud is under DDoS protection. So Microsoft makes sure that anything coming into Azure is under the umbrella of DDoS protection. And then you can also use DDoS protection on your virtual network. Like when you're putting resources under a virtual network and you're building applications, then you wanted to have protection for your own application. Like, so let's say you are hosting a e-commerce application, and it is for the Azure bigger picture. It doesn't understand that you are attacking that particular IP address. It will not know. It will be like encapsulated within that traffic level. So you are trying to hit that particular VM and then take it down. And that one is actually a virtual network level DDoS protection. And there are we have a basic and a standard protection on that. You can actually by default it has the basic, but the standard provides much more protection, and then you can have logging and things like that. So it's out there. I just wanted to point you to that as well, right? So that's also provided. So from a network isolation and protection point of view, this is how it all works. You have the Azure DDoS protection at the outermost layer, and then you have the ACLs. Once you go beyond that, then you have access control lists. Like basically, you can only access things that you are allowed to. And then you have the isolation on virtual networks based on the network boundaries. And then you have NSGs, which I mentioned before, which are similar to your DMZs or demilitarized zones. And then you have the VM firewall, which is also a configuration within the VM. We can actually enable firewall on the VM and then add more stuff to that. And then here in the virtual network isolation, there is also the DDoS protection that you can enable for that. So that's how it protects the whole framework across from any of those attacks. And that actually covers all the network part of the security. If you guys have any questions, please let me know. Now, if not, I can go into storage and data. Okay. Anything there, Tim? Any questions so far?
No, just Sean still earlier.
Okay.
Yeah.
All right, cool. Okay, then. So let's look at the data in Azure. So if you look at the data, there are several offerings that we have: the blob storage, the table storage, queue storage, file storage, and all that. So these are all deployed on top of a massive scale out load balanced layer of storage. And the cloud storage is an object-based, durable, and massively scalable storage subsystem. And what you see is the logical or like the offering that we provide you on the backend system that we have there. So we have more than 25 trillion stored objects. I don't know if this is the latest metrics. Maybe this slide is a little bit old, but you can leverage there are, and I will talk about some of the storage protections that we have. So so this is the framework actually. And at the bottom layer you have a replication layer, and which actually does the geo replication and those kind of things. And on each region you have a massively scaled out storage infrastructure that actually provides you all the services on top of those. And now in terms of replication, this is something that the customers care about, because there are data sovereignty type rules, and we want to make sure that the customers are aware of the replication targets. If you look at these things, each region has a peer location. So basically, East US is paired with West US. So which means that if you are creating a storage in East US and geo-replicating it into another region, then it is going to be replicated to West US. And so this actually gives you the data where the data resides. It is more primarily used for compliance issues and data sovereignty and all that stuff. Like basically, you want to make sure that you are sitting within the same geopolitical region and not traversing outside the region. So this is a published information around data replication. And now, instead of in terms of data protection, the data is segregated using customers. If you look at Azure data storage, like any other system, it's a multi-tenant environment, right? So you are getting the efficiency of storing data in a common environment, and so that means that we have to isolate and protect each customer from having visibility to the other customers, and that has to be very, very controlled and very robust, such that we cannot have any leaks there. So so we have the data isolation that is primarily used by logical isolation. It is not a physical isolation. That's because we cannot have physical hardware for every customer, right? So each customer's data is protected logically from others, and this actually provides you the scale and the economic benefits of the multi-tenant services. And the next thing is data at rest. Customers are responsible for ensuring that the data is stored in Azure is encrypted in accordance with the standards, actually. So we actually provide the encryption capabilities, and by default, all the storage is encrypted. You can actually enable more encryption on top of that, and we will talk about some of those things in the next couple of slides. And data in transit. For data in transit, customers can enable encryption for traffic between their own VMs and end users. So this is all about like using the protocols like HTTPS or TLS or things like that, right? So basically, how you are, like, if you are using FTP, you may want to use a SFTP and all sorts of things like that. So that's the traffic coming from the customer side to Azure is depending on the protocol. So you need to define, like, you need to have that security standards to make sure that your data in transit is secured as well. That's the first part of the discussion I mentioned around some of the responsibilities that are decided within the customer space, and some of them is with Azure. So the encryption management, you can bring your own keys in some instances. Like, for example, if you are doing Azure disk encryption, you can bring your keys, but some of the foundational services you probably cannot. For example, storage encryption is by default, Azure creates a storage key when you are actually building that storage account. And some of those things could be managed by you. Some of those things may not be managed by you. So there is a lot of information in the documentation around what you can do and what you cannot. So the data redundancy. So the Microsoft actually makes sure that your data is protected in at the time of a cyber attack or anything like that. So every storage account has 3 copies sitting in every region. Let's say you create a storage account with a local redundant server, like locally redundant storage. Then you will have 3 copies of that storage within that region. And then if you are doing GRS, like globally redundant storage, then the 3 copies will be copied into the other region as well. So you'll have 3 more copies there. So that's how the redundancy helps you from security threats. We are, I don't know exactly how much is the SLA for that, but then in terms of durability and accessibility and all that, there are pretty good numbers that you can look at from the documentation. And there is also something called storage firewall. If you go to a storage account in Azure, you can actually enable storage firewall. Storage firewall actually allows you to like restrict access to the storage account from certain endpoints only. Let's say by default, a storage can be accessed from anywhere, like any IP address or any public domain, as long as you have access and you are providing credentials to access that. But if you restrict that, you can actually enable storage to be available within a virtual network. You can make a storage as a private storage and things like that. So that's also possible using a storage firewall. And now let's talk about Azure Data Encryption at Rest. Probably I won't go too far into that. Maybe we'll have some more things to cover. So there are different encryptions possible. You can application layer, which probably is mostly by the developer. You don't have to do. Azure doesn't provide a lot of stuff there because your application specific encryption, you can use something like Key Vault. You can put your secrets and certificates in the Key Vault, and we provide you the facilities to do that. And then you use those things to encrypt your data within the application space. Let's say you are pulling some data off of the database, and then you want to encrypt it before sending it to some place. Then that's part of the application process, right? There you can use some of those tools that we have. And for the PaaS services, there are encryptions, and probably I will not cover all of those things now because I think I have some more stuff to cover. But I can provide you the links and everything probably at the end. I think let's look at the Key Vault service. I just briefly mentioned about the Key Vault service. Key Vault is similar to, if you are familiar with the HSM. HSM is a hardware security module. Usually when you are in an on-premises environment, there is usually a device called HSM, which actually stores all your certificates and keys and storage and all that. It has we have standards for that, usually called FIB standards, and some of them are tamper proof and all that. Like if somebody tries to manipulate anything in that device, or like try to retrieve or like do something like that, like overwrite, it will show an evidence of the tamper. So those are called tamper-proof HSMs, and we have similar service called Azure Key Vault, and Azure Key Vault can be, and there is also another service called Azure dedicated HSM, which is actually a physical server that you can actually install for your own usage, just like your on-premises Key Vault or on-premises HSM, but for most practical purposes, the Azure Key Vault service, which is more like a logical stuff, will work for you. Data destruction. So whenever somebody is deleting a data off of the storage account, it is immediately taken off of the index. So it will not be able to. You will not be able to access that with immediate effect. And for the replicas, it is going to be a asynchronous process, which actually immediately kicks off and keeps deleting the replica from the other region. You cannot delete it on the fly because of the physics involved in, like if somewhere sitting in a different region, you have to reach there and then start deleting it. And so, but the thing is that, once you delete it, immediately you cannot access it, and then it is all protected, and then nobody else can also look at it because we are all controlled by access controls and everything. So this disk space will be overwritten within a matter of time, and usually within a couple of days, or and then things like that. So and the other part is like, if there is any disk failure or anything that happens in Azure, they will be shredded and all that. Like, there is a process, there is a standard for that. I don't know the exact name of that, but there are standards for shredding and destroying disks which are not utilized, so that nobody can retrieve anything from that. So that we also follow those processes whenever we are replacing disks in Azure. Let's look at identity and access control. In the traditional world, identity was we usually used to look at security as a tiered approach, like the diagram that I showed before. You start off with the network security, you start with application level security, then you have data security, and eventually you build your security model like that. That is still valid, but the thing is, when you are going into a cloud-based deployment, the security is around identities now, because you have so many systems on premises and in cloud, other cloud vendors. Like, it's a very hybrid environment. So knowing who is accessing this is a very critical element, because you are not confined to the space of your on premises, and there it is. You have a very rigid system, and you have the people, and then you are only looking at the physical, and the layer is at the very low level. Now, when you're looking at a cloud infrastructure, we wanted to model your security around identities. I want to understand that who is accessing, even if I'm protecting against all the other known aspects. I wanted to connect all the activities of a single customer and understand what he or she is doing, and are there any breaches or things like that. So security around identity is very key in a cloud-based system. And that's where Azure actually has a lot of advantage. Actually, we have Azure Active Directory, which is used across multiple variety of use cases, and which is actually shown here. So we have Azure AD Connect, which provides you the synchronization of your local identities into Azure. So if you are using Active Directory on premises, you can synchronize that with Azure Active Directory, and then the common identities will prevail across multiple domains. And you have things like Azure Active Directory, B2B. You can bring guest users, or there is B2C also. If you have customer identities that you wanted to use, then you can use B2C. And you can also do service principals, which are like system accounts and things like that. There is a variety of stuff that you can do in Azure Active Directory. So it's a single identity platform that we provide across multiple realms of existence. All right. Think I will skip this slide. Let me see. So a couple of slides around operations and governance. So if you are not familiar with the application, the hierarchy of Azure, a customer gets an enterprise agreement with Azure. Let's say a company A comes and buys Azure. They start off with an enterprise agreement. So they have an enterprise portal, and where they create this agreement. This agreement could be pre-committed, like they give X amount of dollars in advance to Azure, Microsoft, and then we will actually take away based on consumption. Or it could be a pay-as-you-go model, where they pay every time after they consume. And then the enterprise agreement once the enterprise agreement is established, you will have departments. Departments is an optional concept, but then this is all for granular and roll, for more granularization and rolling up your accounts. Basically, you can have departments, and then you can have accounts under these departments. And as a developer and a user, or like a builder in Azure, we are all focused on subscriptions. The subscription is the technical boundary, and also it's an accounting boundary for Azure, where you have rolling up all your utilization within that subscription. And you can also roll up across accounts and then departments and things like that. And then within subscriptions, you have resource groups, and then you have resources under that. This is how the hierarchy works. And then we have role-based access controls starting from your subscription all the way to the resources level. And the role-based access control is basically, you can have standard Azure roles. It comes with the pre-built roles, which you can apply to everything. And there is a hierarchy of roles. Like if you apply at a subscription level, it actually applies to everything below that, like an inheritance rule applies. By default, we get contributor, owner, and reader access. One of those things the user can select. And there are several roles like database administrator or whatever it is. Like I mean, you can look at the number of roles there, but you can also create custom roles. The role definition is a JSON file. You can pick and choose certain things. Let's say you want to have a user who can only restart virtual machines. He's an operator sitting in somewhere, and then their job is like to shut down servers and restart servers at some point based on a request. So you can create a specific role for that particular user, saying that VM operator, something like that, and then they can only do whatever pre-selected conditions that you apply, or access rights that you apply to that particular role. That's one way of controlling access as well. Then there is something called Azure policies. This is for all about governance. Azure policies actually provide you auditing across all your assets, and also some sort of proactive controls as well. So basically what Azure policy does is we define what is a compliant rule looks like in Azure. Let's say we are saying that this subscription cannot create a virtual machines of type FV version 2 or something like that, or like more than that, some of those machines. You can create as an audit rule. So what happens is once you deploy that, first of all, you define that policy, and then you deploy that policy into one subscription. The definition of the policy is one thing. You define what that policy means, and then you deploy it into a scope. You can deploy it into a subscription scope, or you can deploy it into a resource group scope, wherever that policy applies. And once that is applied, what happens is it keeps probing what is there, and then it actually provides you audit numbers. So basically how much of that is compliant and how much it is not. And that's one way of, that is more like a reactive type of policies. But then there is a proactive policy. You can also provide policies such as like, don't do some things. Let's say you cannot deploy in this region. If you create a rule like that, somebody is trying to install something in the region, then it actually doesn't allow you to do that. So that's more like a proactive type of policies. So you don't have to write, you don't have to babysit each of those things that you're doing. This is enforced at the policy level, and then that actually makes life much easier. The other way of doing it is there's also something called append policies, where it keeps adding stuff on top of it. Let's say if you have some standard tags that you wanted to put everything, and if the user is not providing those things, it will append those, and while deployment it will append that and then put those things as well. So these kind of policies you can enforce, and that is actually making sure that you have governance at scale on your environment. Like you're not going in one by one and looking at these things. This is sitting at the background and looking at all the components and providing you with a governance model. The second thing is called the blueprints. The blueprints is also a governed subscription. So basically you can build blueprints using policies, network rules. Then you can also have RBAC rules and some of the essential elements that you need in the subscription. So you can create a governed subscription. So every time you create a subscription, all these essential components of that subscription will be coming into picture, right? So basically it provides you the landing zone, we call it, like, it provides you the basic infrastructure or the controls around that subscription. And so that you don't have to like do it every time. So let's say you have, whenever you create a subscription, you need to have the basic, let's say one resource group called the management group. And then there's another subscription called another resource group called application group. So all these things will automatically be created when you create a subscription. So you can create blueprints by weaving together all those concepts around security and policies. That's the blueprints. Are we tracking on time, Tim?
Yeah, I was just going to ask you about the blueprints. Can you be audited right after you implement resources with the blueprints feature and be in compliance, or what is that? I mean, that must be pretty substantial.
Yeah, so the blueprints actually provides you the controls before you create something, right? And basically that means that you can put those things in place, but you can still continue to the blueprints will come into effect at the time when you build it. Like it's kind of a stamped item, right? So it doesn't mean that you can break those things afterwards. You can continue to build on top of it, but then you can continue to enforce using those with policies. Once it is created, it is just like another subscription, right?
Gotcha.
But it will give you some starting point.
Gotcha.
Yeah.
Hey, we have a question. Do you have any suggestions for implementing DevSecOps? Maybe free tools or scripts for DevOps teams to monitor and manage?
Yeah. So there are two tools that actually Microsoft provides. I think I was going to talk about that in the next slide.
Okay.
Let's. I think probably that I don't know the exact answer to that, but then maybe it is a little bit different. We can talk about this, and then I can also talk a little bit more on that particular thing. Right. Anyway, so SecOps is there are two tools called Azure Security Center and Azure Sentinel. One of the things that Microsoft provides is like all our tools are friendly with on-premises and other clouds. So we provide hybrid tools. Like these are all connector-driven tools, so it can get telemetry from anywhere, not just limited to Azure only. So the Azure Security Center is an identification and protection mechanism. So it gives you the state of your security posture, right? It gives you your security score, where you stand in terms of security, what are the vulnerabilities, what are the things that you need to do, like recommendations and things like that. It's more like a static picture of how you are doing now, and then what are the corrective actions you can take. So that's the first part of it. That comes under the identify and protect stage. And then you have the threat mitigation and security process. That's actually a process called Sentinel, a tool called Sentinel that provides you the detection, response, and recover part. So that is more like an operational tool where security engineers and the team are actually looking at it. Like it gives you on incidents and threat mitigation and graphs and all sorts of tools to mitigate the incidents. And the first one is more on the framework level. So that's kind of the difference between these two tools. But between these two tools, it gives the full coverage around your security posture, actually.
Nice. Azure Security Center and Azure Sentinel.
Yeah. So yeah, security. I can actually show you a demo or a little bit, at least a screen of Security Center. So yeah, this is. Let me just go through the Sentinel. I think I will not go too far into that, but there is some automation also in Sentinel. Like for the SecOps, the question that asked, you can actually do playbooks and an automation and all that as part of if you are enabling Sentinel, you can have hooks into that and then do a lot of things in your SecOps process. Or the other way is like if you are using Azure DevOps, you have probably I mean, I have not looked too much into that, but then I'm guessing that there could be some connectors to all these tools from Azure DevOps where you can write your own pipelines and stuff like that to do some of those processes as well. But by default, we actually provide these type of things. But if you have a few minutes, I can actually show a couple of slides as well.
There's one question about, and I think we already have Azure Government. There's what does Microsoft Azure Security, or does Microsoft Azure Security meet federal government standards, security standards?
Yes.
If not, what can we add or combine so the Fed government can use Azure services? There's an entire government cloud for different levels of security for the federal government.
Right. Yeah, there is. So I did not talk about the compliance of that, right? So this is all about, there is another thing called compliance, right? So basically, we have published all the compliance, that we provide based on there is like, if you look at the Microsoft Trust, I think it's called Trust Center, right, Tim? Yeah. Right, they have all that stuff, right? But, I don't have the slide, but I used to show that in other presentations. But this was mostly around security, so I didn't include that. But I also show you something around Azure Security Center. So the Security Center itself gives you a security score to start with, like how you're doing with that. And then and also gives you regulatory compliance also. This is actually another cool thing, like how much you're compliant with these kind of compliances, right? It actually gives you suggestions to improve your compliance. And by default, Azure, provides you the compliant. There are two things. Like Azure gives you the compliant environment, but when you are building a tool within that could be non-compliant because you are the way you have built it, right? So that's where this regulatory compliance findings will provide you. Then, if you look at the security score here, it comes up with so many recommendations. Secure management boards, then all those kind of things. Like basically, I'm not pretty good here, right? So I have to do a lot of stuff to secure all these things. But it actually gives you all that stuff. But if you have another few minutes, I can show you the Sentinel. Sentinel also comes up with the. I think this doesn't have a lot. Sorry, I think I may have to look at another workspace. Yeah, so it actually shows security events and a lot of stuff here. And you can also do some hunting here and see, any of these things are happening. Like you can run all these things and say any policies changes, all these things happening here, and it's a lot of stuff. It is pretty complicated also to use. You have to get used to something. But then there are also incidents where I don't have an example, but what if there is an incident, then you can actually see these things like investigate incidents. You can actually double click and go into those things, and it will give you all these this an anonymous login, and then where it is coming from, and all sorts of chaining of all that stuff. It gives a very good picture, and then it will give you what kind of mitigations you can say, suspicious activities, and it is a pretty robust tool with that. That's about secure Azure Sentinel, but I don't have a lot of time to show all that stuff, but it's pretty cool.
Thanks, Jake.
Yeah.
Azure Security Center and Azure Sentinel, two really good tools for the securing your Azure tenant and the resources that you have in there.
Yeah, and you can also connect with the external SIEM tools. Like if you are using Splunk, for example,
right.
you could send all these telemetry into that using an event hub integration. Event hub is like an eventing, high-speed real-time eventing mechanism where you can take billions of data and then pass it over to another receiving system.
Very cool. Very cool.
All right.
Well, guys, is there any questions before we let Jay go? Any questions? Any other questions that we had? Doesn't look like it. Well, Jay, thank you for your time this afternoon, and everybody, thanks for joining on. And we've recorded this session, and we'll post it up probably by the end of the day, if that's okay with everybody.
Thank you, Ken. Thanks, Tim.
Sure, Jay. Thank you. Thanks, Prashant. See you guys later.
Bye-bye.
Bye-bye. Stop recording.